Uh, let us enter into new paradigm of Python. Generally, the Python is a very good programming language for visualization. So visualization with Python. See, no doubt we are seeing different types of programming in Python. Now, visualization is plots. How do I take a what you call take dumb data and create a plot, a graph, so that I can visualize the data um, with ease. So there is one library called matplotlib. I think you can see. I went into the website directly of what do you call Python. Matplotlib is a visualization with Python. Matplotlib is a comprehensive library for creating static, animated, and interactive visualizations in Python. So, uh, and so it will take all the data, whatever you data you give, it will try to give an example or a visualization of the plot. Okay, see, there are certain things here: create publication quality plots, make interactive figures, customize visual style and layout, export to many file formats, and many things are available. Okay, let's look at this. And this is getting started, examples, reference, sheets, and documentation. So let me go into the examples first. So there is a uh, or I want to create, I want to go to get started. So in this getting started, there is a quick guide, right? So pip install matplotlib, and then followed by there is a graph. But before going to the directly going to plotting, I would like to let us actually understand some few basics. uh, in what way matplotlib tells us to create. See, I am showing you a what you call mind map, which is I have utilized the what you call notebook LM, in which I am trying to get this particular learning material. So this is matplotlib, right? And then there is something called programming paradigms. So you can see there is an explicit or implicit. Implicit is pipeline, explicit is object oriented. Okay. Then if I come to the anatomy of a figure, suppose say if I create a plot, any visualization tool figure. So what is that? It's like a canvas where we draw something. It has a axis, individual plots, scales and text, and many more visual elements inside. That means legends, other things, title. What is the workflow? See, standard, how do I go about writing a program in Python in a editor, like, suppose say Jupyter. Okay. So first what we need to do, we need to actually take as a first step, it's a import matplotlib, prepare the data, set up a figure or axis, that means how much dimension and plot the data and customize the data and save or show. See, this is how the flow of the program should be in our mind. It's as if an algorithm going on. So there are 6 steps where we can actually look into. Okay, what are the different plot types actually? There are different plot types available in this library. Line plot, it is actually showing us, how it is being shown, saved also. Scatter plot, bar plot, histogram, special, pie plot, polar plot, box plot, like that. There are other libraries in which we can actually get to know, but this is the number one, and we are seeing the flow. The next, yeah. So let me actually look at this. Yeah, this is the common plot types. What you are trying to look at. So customization. If I go to the customization, see what is the customization? It's a styling, color maps, and layouts, right? So styling, again, see, line styles and markers, built-in style sheets, colors and alpha, right? So this is again one more thing. And color maps, you know, so different types of color maps are available. We'll explore. Even I am trying to learn this also. So this is the customization of the plots. Okay, let me take out all these things. Now outputs and best practice. You're saying, this is I am utilizing a tool called AI tool, which is NotebookLM, and it is how best practice, how it can be, how we can actually do it as a best practice. So it's a display. See, Nick, look at this, Then look at this. Look at this. It's first of all a display, and you have to say how to display. How to display plt.show. Show is a command or a function. Accessibility and clarity. That means labels, title, legends, many things. Okay, right. So this is what is a what you call a learning for us from one of the AI tool which I have taken it so that it will be easy for you. Now, let me take this particular program. You can see, and let us analyze each what you call line in that. Okay. Now, let me paste here, and then let me actually do it like this. Now look at this. Now, if I show you this little more down. Yeah. So what is happening here? So there are certain commands which we have to understand. See, import. First, let me run this. Let me run this. Let's understand how the curve is being generated. And mm, this, if I run, see, there is a star which is being shown here. That means it is actually running the program. See why it is taking some time, because in my editors I am working on Zoom, then I opened YouTube, then I opened another AI tool in another browser. See, now the plot is ready for us. See, the plot is ready for us, and what we need to understand is little bit more. See, there is a x-axis here. There is x-axis of 0 to 7 scale, and y-axis from above axis and below axis. There is a 1 to -1. So what is this is the total curve which shows a what you call wavy nature of the curve. So let us understand what is this type of the curve. They generally it represents sin x, sine or cos, because it is starting from 0. Generally it is a sine wave. So what is the first step? It said import matplotlib.pyplot as PL, because every time in this library, every time we will having many functions called plot or show, something as subplots. So we don't want actually that way to happen. So here, see, we are importing matplotlib.pyplot as PLT and import numpy, because numerical Python also we need certain arrays to be taken. We need some mathematics. X is equal to C np.linspace. That means it's creating a 0 to uh, 2 into np.py. See, pi is again a numerical value which is available in the numerical Python library and numpy. So pi is known as 3.14, 2 into 3.15. So 0 to 3.14, it is taking around 200 values here. So 200 values here means 2 into 3.14 roughly around 6. 6 minus 0 divided by 6 minus 0 divided by 200, you will get 200 points. Then the curve will be very smooth. Then y is equal to np dot sin x. Actually, this is the function. See, y is dependent on the x is an independent variable, and y is a dependent variable, and x actually we are giving a what you call values ranging from 0 to 2 into 3.14, roughly it is coming around 7. Now look at this, in the x-axis you can see this is the last point. This is more than 6, right? So 2 into 3.14 is roughly around 6.28. Okay. Now figure comma ax is equal to plt dot subplot. It actually take one more things like this. But if I this is one, and ax dot plot comma xy. So instead of that, if I generally just do this, if I try to do x comma y, will it plot? See, let me actually do this as a comment and then do this as a comment. I'm just using a plot command here, but if I run this program, will this run? See, generally plot is not a function we have to use directly. It is available in the library. Yeah, there is an error. So plot library, that means we have, yeah. So let me come down here. I will say plt dot pyplot and then again run the program. Let us see now whether, see, now it is running. See, the program is actually showing subplots which is being created, but I don't want that plots to be created as a plot. And certain variation now, fake, comma, or I can say ax is equal to uh, plt dot plot, and this is plt dot plot. Uh, plot I say, and then Mm, I take this as ax is equal to something. Let us run this again. See, again it is running. This that means we are trying to store all the things. No, not like this. And I want to run this like this. So see, oh my goodness. So it is not running actually. It is little problem. So PLT fig gamma ax is equal to PLT dot plot and fig. Okay. Let us not delve too much because we want answers and readily we should understand each and every syntax first. Otherwise, it will be a big trouble for us. So what exactly this is coming? So this is x comma y. Let me take this down and then let me run it again. So now see. Now this is the program which we are running. Okay. Right. We will again come back with another example and then we'll explore more.